see what we got. We'll just run through the last of these practice questions for today's science class and call it a day. So yesterday we did roughly half of these practice questions from the science practices review section. So today we'll kind of go through the rest of them, the ones we didn't get to, and post it up to the YouTube channel. So hopefully some of you can go through it on your own and review these practice questions. So number 5, I'll just start reading and go from there. So number 5 says, while all types of cancer share the common trait of uncontrolled cell growth, the causes of that uncontrolled growth are complex and varied. Nevertheless, a number of specific causes of several types of cancer are known. For example, long-term asbestos exposure can result in mesothelioma, a cancer that can affect multiple organs. While long-term regular inhalation of tobacco smoke can lead to lung cancer. In addition to such chemical causes, viruses are also responsible for a number of types of cancer. Human papilloma virus precipitates cervical cancer, while the hepatitis B virus causes liver cancer. Use the information above to place 4 specific types of cancer from the list below into the left side. Place a corresponding cause of each as identified in the passage above to the cell immediately to the right. So this is just, can we organize the information they gave us, right? So they said that all types of cancer share a common trait, but a lot of the causes are unknown, but they mention a few specific causes of a few specific types of cancer, and so they're just asking you to match those up. Okay, so let's go through them. First one they mentioned, mesothelioma, right? And it is caused by long-term asbestos exposure. It says right there. So mesothelioma goes there. Long-term asbestos exposure goes there. All right. We've got lung cancer. Will be the next one. Long-term inhalation of tobacco smoke would go there. The third one mentioned would be cervical cancer. Cervical cancer would be the third one, and that's caused by the human papilloma virus. And liver cancer would go the fourth one, and its cause listed here was hepatitis B virus. Okay, according to this, right? So that's all we're doing. It's taking the information from the paragraph, matching them up. So most of the questions on the test are definitely going to be multiple choice. We'll certainly get some kind of this drag and drop matching type of style questions as well. So kind of FYI. All right, let's look at these 4 questions here, numbers 9 through 12, and they discuss this. Oh, must have bumped something. I was paused for a minute, but I'm not now. Okay. So long passage, but all 4 of these questions deal with it, with this passage. So I'll go ahead and read through it kind of briefly. So the passage states, an office manager noticed that each time she touched the metal filing cabinet next to her desk, she experienced an electrostatic shock, commonly known as static. Her assistant, however, only rarely experienced such shocks when touching the cabinet. The office manager wondered why this might be. The office manager developed a thesis. Perhaps differences in clothing could explain why she was experiencing more shock than her assistant. The office manager liked to wear nylon clothing, and her assistant usually wore cotton clothing. To test her hypothesis, the office manager convinced her assistant to wear nylon clothing to work every day for a week, while she herself wore cotton clothing. Next week, they switched. The office manager wore nylon clothing, and the assistant wore cotton. To control for the possibility that the differences in shocks were due to differences in their footwear, they wore identical shoes each day. During the experiment, both the office manager and her assistant recorded the number of times they touched the metal filing cabinet, and they also recorded the number of times they experienced electrostatic shocks when doing so. At the end of the first week, they found that the assistant had experienced 73 shocks, while the office manager had experienced 10. During the second week, the office manager experienced 68, and her assistant 12. The office manager concluded that these results supported her hypothesis, and as a result, she decided to switch to wearing mostly cotton clothing. Okay, long paragraph, but good example of something that we should go over because this is a scientific method question looking at, hypothesis, setting up an experiment, running an experiment, analyzing data, which we've talked a couple times about, and you can definitely expect something like this on the test. So good thing to make sure that you go over with and make sure you're steps in the scientific method. And can you follow these steps on your own, right? Can you set up a hypothesis, test, and analyze the results from it? So number 9 says, scientific investigations begin with a question. Which of the following is the question that formed the basis for the office manager's experiment? So, what question led to the office manager conducting this whole experiment? A, is it better to wear cotton clothing or nylon clothing? B, why does touching the metal filing cabinet produce more electrostatic shocks than touching other office furniture? C, why, when I touch the metal filing cabinet, do I experience more electrostatic shocks than the assistant does? Or D, could my shoes be causing me to experience more electrostatic shocks? Again, based on what we read, what is the question that the office manager, why did she go and create this come up with this hypothesis and come up with this experiment? Well, definitely wasn't A, it is better to wear cotton clothing or nylon. Like that idea came later, right? Why does touching the metal filing cabinet produce more shocks than other furniture? Well, there is no mention of other furniture in there. It's just talking about the cabinet. It's not B, right? Really, to me, the easy choice here would be C. Why, when I touch the metal filing cabinet, do I experience more shocks than my assistant does? That's really what drove her to do this whole thing, okay? Number 10, which of the following best summarizes how the office manager conducted her experiment? Okay, let's look at the options. A, the office manager suspected that her nylon clothing was causing her to experience electrostatic shocks. B, the office manager switched to cotton clothing after seeing that her hypothesis was supported by her data. C, the office manager wore shoes of a different material than those of her assistant. Or D, the office manager wore one type of clothing. Her assistant wore another type of clothing, and they recorded the number of shocks they experienced. Okay, and again, we're looking to see which one of the following best summarizes how the office manager conducted her. Okay, so in other words, how was the experiment set up? Okay. So, for example, B, the office manager switched to cotton clothing after seeing that her hypothesis was supported. That came at the very end, right? That is the conclusion, or even after the conclusion. Once she concluded that her hypothesis was true, then what she did with that information, how she analyzed it, right, which is the final step, she switched what type of clothing she was wearing. So that realization didn't come until after. It's not B. We're looking at how the experiment itself was set up. Okay, and C isn't right either. The office manager wore shoes of a different material than those of her assistant. It does say in the experiment they wore what? The same shoe, right? So it's either A or D. The office manager suspected that her nylon clothing was causing her to experience electrostatic shocks. That comes before she formulates the hypothesis. She comes to this realization before the experiment. So the only one that really describes the actual process of the experiment is D, right? She set up this experiment where she wore one type of clothing and her assistant wore another, and then they recorded the number of shocks they experienced. Right? D's your best answer choice out of these four. Okay. Number 11. Why did the office manager and her assistant wear the same type of shoes while conducting the experiment? Okay, so what was the reason behind wearing identical shoes? A, they wanted to test the effect of their clothing on the number of shocks they experienced, and wearing different types of shoes might have confused their results. That sounds possible. Let's keep reading. B, they wanted to test whether the office manager's shoes were causing the high number of electrostatic shocks she was experiencing. We know that's not right. The shoes weren't the dependent variable. They were not what was being tested. Right, let me back up. I meant independent. Right? The dependent variable here is electromagnetic shock or electrostatic. So the variable they're testing is clothing. They're not specifically not testing shoes, right? So they wanted to make sure they eliminate the possibility that shoes might change the results. So it's definitely not B. C, they believe that wearing cotton might cause the wearer to experience more shocks. No, they believe the opposite of that. So C isn't right. And D, they wanted to protect themselves from the effects of electrostatic shock. No, they were purposefully shocking themselves, essentially, right, for an experiment. So really, the only one that makes sense is A, right? That's why they wore the same shoes. They wore the same shoes because if they wore different shoes, then they could say that maybe the different shoe was impacting the electrostatic shocks and not the clothing, but they were testing the clothing, right? So that they wanted to make sure they isolated the variable that was being tested. All right, and then lastly, number 12. Imagine that the results of the office manager's experiment had demonstrated that her clothing was not, in fact, responsible for a large number of shocks. After reviewing those findings, the office manager then wondered if her footwear might be responsible, and she decided to conduct a new experiment to test the idea. Before she conducted that experiment, the idea that her shoes might be responsible would be which of the following? A, a new conclusion based on findings. B, a general principle from the study of physics. C, a new hypothesis. D, a new experiment. Okay, so we're just talking about the idea. She runs in the scenario presented to us in number 12. She runs the experiment, but actually finds that the clothing doesn't seem to be impacted and that it's maybe something else. So she decides to, she has a new idea that maybe it's the shoes and not the clothing. So eventually she will set up a new experiment, right? So D is a decent one, but also could be C, right? It's not A and it's not B. A new conclusion based on findings. No. Because the way the scientific method works is if your hypothesis is disproved, you've got to go back to the start and do what? Reformulate your hypothesis. So it's not A and it's not B. And the reason it's not D is because we're just talking about the idea of switching the hypothesis, which comes before switching up the experiment. And so for that reason, C is a slightly better answer than D. Make sense? All right. Let's just go through these last two questions really quickly, and then we're going to call it a day or science. Call it a week. 13 and 14 say you may use your calculator. So calculator out in case I need it. 13 says common garden snails are hermaphroditic. That is, each individual snail produces both sperm and eggs. Mating between two garden snails involves the transfer of sperm from each partner to the other. A high school science teacher has created a large terrarium for his classroom that contains 6 adult garden snails. Assuming that all snails are healthy, how many different mating pairs are possible? So we didn't actually talk about this. To solve this, we would basically make a chart. I don't necessarily think it's worth making a chart right now, but if someone out there wants to go over combinations and how you figure this out, we could. What I would say is, and just kind of talking about this in general terms, I would assign the 6 different snails a different letter or number or name, right? Name them if you feel like it, but you could call them snail A, B, C, D, E, F, right? And then mating pairs are pairs of 2. And so out of those 6 different letters, see how many combinations you could make. In other words, A and B, A and C, B and C, A and D, B and D, so on and so forth. And if you do that, do as many as you can, and typically I make a chart. And again, if someone out there wants to go over this and do this, we definitely can. At some point, we'll get to it in math class. But really what you would do is if you found all of those possible combinations, first of all, you may not find them all because you might just not think of them. But you're going to get close enough to probably make a pretty good guess, right? And in this situation, if you do that, the right answer is actually 15. Right? But say you find 13. Maybe you find 14. Maybe you can't find the last one. But you know it's more than 12 and way more than 2. Is it likely that you can find 15 or 20 more? Probably not, right? So, you know, use the multiple choices to your advantage and see what you can get, right? See what kind of help you can get. And then let's look at the last question. Number 14 says, the sun is a class G star, which is a type of main sequence star. Approximately 90% of all stars in the Milky Way galaxy are main sequence stars, and approximately 7% of all main sequence stars are class G stars. What is the probability that any given star in the Milky Way galaxy is a class G star? Okay, so let's break that down. Okay. Again, let's see what we're looking at. We are trying to figure out, this is a tricky little math question, right? What is the probability, or what are the odds that any given star in the Milky Way is a class G star? And we know that approximately 90% of all stars are main sequence stars, and approximately 7% of those are main sequence stars. So if we start with, and first let me see what how the book explains it. But I think they're going to do it slightly different than I would do it. But let's just see. So the question asks for the probability that any given star is a class G star. So what you have to do are combine the 2 probabilities to find it. So when they say combine, they mean multiply together. So on one side we have what percentage of stars are main sequence stars? 90%. So the probability that the star is going to be a main sequence star is 9 out of 10 or 90%. So if we take 90%, which as a decimal is 0.90, right? 0.90. And if we want to figure out what the probability that the star is going to be a class G star, we have to multiply that 90% by the odds or the probability that that main sequence star is also a class G star. So we multiply 0.90 by 7%, which as a decimal is 0.07. Not 0.70, 0.70 would be 70%, 0.07. And if I multiply those 2 things together, I get 0.063, which if I convert that into a percentage by moving the decimal place to the right 2 times, right? I get an answer of 6.3%. Because it does say express your answer as a percentage. So the odds that any given star in the Milky Way is a class G, like our sun, is a 6.3% chance. There's a 6.3% chance that that is. Make sense? All right. Well, that is all I've got for science for the day and for the week. So hopefully that was helpful for those of you that were able to tune in. Otherwise, I will, man, today has been a long day, I suppose, talking to myself. Anyway, I hope everybody has a nice weekend, and I will see everyone back for classes next week.